Hi, I'm Alice Lee. I teach second grade at the Crescent Park School in Bethel, Maine, and I'm going to explain how I got started integrating computer science in my elementary classroom. I was motivated by the I2I grant, with the driving question being, what are ways that I can successfully integrate computer science into the already existing second grade curriculum, and what is gained from integrated lessons? I looked closely at these key computer science concepts for second graders, and I branched out and looked at ways I could weave these concepts into the subjects that I teach. I started by building a foundation for my second graders using a free curriculum called CS and SF, and I'm going to show you that. When you go to the site, under curriculum, there are the grade spans. And I went to K2 Creative Computing. And there's a chart that helped me determine what level my students were at. And I determined that the orange was where they should start. And I wanted to start by building that foundation of unplugged concepts. So I started with Unit 1. There are 6 different lessons, and they are Ruby's algorithms, dance loops, big events, dress code conditionals, peanut butter and jelly algorithms, and Rosie's runtime. And when you go to those lessons, they are laid out for you. So lesson 1, you can view the lesson plan, which tells you minute by minute how you can teach it. You can also personalize that. You also have materials. You can buy the book Hello Ruby by Linda Lucas, or you can use the PDF that they supply right here under materials. So you've given an agenda, vocabulary, standards, and additional resources. So that is where I began. In lesson 1, you are provided this activity where you help Ruby visit her friends by writing an algorithm to avoid the blue water, cross the brown bridge, and say hello to each of her 4 friends. Your students start by learning these 4 commands: go right, go left, go down, and go up. This is Lucy's work. She started by helping Ruby visit her friend the penguin. Here are some pictures from some of the unplugged lessons. They add a lot of art and movement, which are fantastic opportunities for our young learners to understand the concept of an algorithm, but do it in a very active and artistic way. After building a foundation with unplugged lessons, I wrote a grant and got my classroom a few B-bots. And I questioned, how does a B-bot help integrate computer science with curriculum? What skills do B-bot activities build in elementary students? B-bots definitely add an element of play. In an NAEYC article about the importance of play, Lori Bongiorno states, children learn through their play. Think of it as a science lecture with a lab. Play is the child's lab. Using the B-bots help develop cognitive skills, physical abilities, new vocabulary, social skills, and literacy. Also, the 4 C's are so important for us to be incorporating in the 21st century classroom. So collaboration, communication, critical thinking, and creativity are key ways for our kids to be learning, and the B-bot really brings this out. There are curriculum connections. So in math, social studies, science, and literacy, I looked at the curriculum and I came up with activities that I could use with the B-Bots. So the B-Bot is sitting in the middle, bringing an element of play, touching upon the curriculum, and also the 4 C's, where my students are collaborating, communicating, thinking critically, and creatively. The B-Bot commands are forward, back, left, right, clear, pause, and move. I have a lot of different literacy storytelling mats because in 2nd grade that is one of the standards. The fables and the folk tales. They enjoy retelling the 3 Billy Goats Gruff. They start here, and after hearing the story, they work in a small group setting, retelling and sequencing the story. I have a lot of science mats, including some life cycles, like the life cycle of the owl. Some math mats that I use. The one on the left, I worked with kids on addition with regrouping and then rounding. So we use that way. And the mat on the right, some subitizing and some fact family work. In social studies, we do landforms and waterforms, and we had a lot of fun picking a card, and the card would take us to like a volcano, and the student identifies the volcano on the mat and then takes the B-Bot on a journey to find the volcano. There are also task cards that accompany the B-Bot mats, and the mats fold up. Here are B-Bots in action. Caitlin was very proud because she wanted to make the journey for the B-Bot a little more complicated, so she sent it in the backwards direction. And that is when I used the B-Bots with the entire class. I had all kids in small groups, and it's a more hectic atmosphere, but everybody's engaged and having a great time. That's one way to use the B-Bots. Another way is as a center, where other kids are doing independent work and there are 1 or 2 groups of students using the B-Bots. In this situation, I had a volunteer using one storytelling mat while I used another storytelling mat. So this is a reading group.
Awesome. Good.
As you can see, the students are very engaged and they definitely have a sense of accomplishment and pride when they program their B-Bot and it goes to where they want it to go. Now I'd like to tell you about how you can make a B-Bot mat. The first thing I did was I built a template so I could use that over and over again for many different mats. And I use a shower curtain, and I traced squares that are 15 centimeters or roughly 6 inches. And I use that template to trace and make the new mat. And then I make or buy cards to fit lessons, looking at my curriculum, determining what I want to teach, then I would find cards that match. I actually took the life cycle of the sea turtle and put it in 2 different ways. I put them out of order for kids once they had experienced telling the steps in order. So there's lots of different ways you can make your mats. So once you print your cards, you can laminate them along with some blank white squares and then lay them out on your mat. And you can use clear packing tape to tape down the pictures. Then you cut out and laminate your task cards. You can also buy a transparent pocket mat, and then you can switch out the cards to coordinate with your lesson. And at the time that I'm making this screencast, I found one for $53.64 for the mat, which I think I'd really like to have, and I think it would be super for storage and easy to take the different cards and put them in. So I think that would be a great mat to have. So thank you for your time. And I hope that you learned something about getting elementary students started with computer science, starting with some unplugged concepts and working into plugged lessons.